Okay, in this video we're going to be talking about sets, and it covers all the extra AKS that's not in the book. So you're going to have to be paying attention to these videos or me when I'm teaching you in front of the class. But let me just go ahead and kind of warn y'all at the beginning of this is that this section or this video is going to be very definition heavy. So you might have to pause the video if I'm going too fast to be able to get all the information down. So let's go and get started. The first thing we're going to be talking about is a set. And a set is nothing more than a collection of objects. So if you were to look at the example that I gave you right in front of you, you're looking at set A. Okay, this is the name of it. It's going to be set A, and this is everything that is in set A, all the different elements. Now, which brings us to the second uh, vocabulary term is that an element or member is all the objects in the set. So the members of set A are A, E, I, O, U. Now, usually all the sets will be labeled with a capital letter, or let me restate, all the sets that you're going to see this week will be all in letters. And then, of course, everything that is not in, or everything that is a member will be labeled in lowercase. Or let me restate, everything that you're going to see this week will be in lowercase letters. You could find it in capital letters somewhat, sometime else. But let's keep going. Now, rather than actually writing out, like, let's go back to this one. See how um, set A was A, E, I, O, U. So those are the vowels of the alphabet. It could also be written in a more algebraic format where rather than actually writing out the different letters, it could just say X is a vowel in the English language. So rather than actually giving you the members, I can give you a definition of what each is, and then of course from there you can make your observations that, oh, it could A, B, let's see, X is a vowel in the English language. That does not work with that. So A, B, and C. So you would say E, A, E, I, O, U. So that was a mess up on my part. Let's try another one. Here's another example. Rather than actually um, writing out the girls in the class, I can just say, in set B was X, and X stands for all the girls in the class. So from here, I could say, in set B, you had the girls in the class, Jamie, Sarah, Jessica, Aaron, so on and so forth. So I can actually a just give you the list, or I can give you a definition like we just went over. So let's keep going. All right. Another symbol that you're going to need to know, or actually I haven't talked about symbols, so you're going to need to know a lot of symbols in this section, okay? The first symbol is this thing right here that kind of looks like an E, and it means is a member of a set. Okay, so now you always be given a set to go off of. All right, so it's set A, A, E, I, O, U. So set A is a member of, I'm sorry, little a, letter A is a member of set A. Okay, moving on. The principle of extension. If two sets are equal if and only if they have the same elements. Notice that set A had elements 1, 2, and 3. Set B has 3, 2, 1. They're the exact same. So you would say that A and B are equal. Remember, I'm going to go pretty fast, so if you need to pause the video and replay something, feel free to do it. All right, moving on. A null set is a set with no elements or members. So like, for example, um, if you were looking at this set here, you have set A, B, C, and then you have set B, which is E, F, G. You could also have set C, which has nothing in it. Okay, then of course you might ask a question, well, why do you even need a set C if there's nothing in it? Which would be a valid question, but we're going to be dealing with situations where this is actually going to have to be practiced. So set C, you could say, has nothing in it, so it's a null set, or what I would call an empty set. Now let's talk about a couple of set combinations. And basically what we're doing with set combinations is where we're going to be taking multiple sets and either bringing them together to see what elements are the same, or separating them to see what elements are not, so on and so forth. We'll get into it. All right. The next symbol you're going to need to pay attention to is this symbol that looks like this. And this symbol means fully engulfed. Now, I used kind of like a Venn diagram going back to language arts to kind of show exactly what we're dealing with, kind of give you a visual. But let's look at set A, for example. Set A has 2, 3, and 4 in it. But if you look at set B also has 2, 3, and 4. So basically what's happening is that everything in set A is located in set B. So that means all the members in set A are present in set B. So you would say that A is engulfed in set B. Moving on. So like, let's say if I give you an example where if A represented the vowels in the alphabet and B, set B represented all the letters in the alphabet. Well, or all the vowels a letter and isn't all the letters in set B. So the answer is A fully engulfed in set B. You would say yes. Yes, it is. Next one. Now, two sets with nothing in common would be represented in our null set symbol here, which is basically a 0 with a little line through it. Now, if you notice set A, I didn't actually write them out, but I did give you like a little Venn diagram example here. You have set A, which is 1, 2, and 3, and then set B, this A, B, and C. There's nothing in common here. So you would say nothing in common. Let's move on. All right. The next symbol that you need to pay attention to, I already have it circled in blue here, is basically a U that's upside down, and is an intersection. And it's when sets, an intersection is basically when sets have shared numbers. So once again, go to my visual here. Notice that in set A, we have 4, 5, 6, and 7. And in set B, we have 6, 7, 8, 9. 6 and 7 are present in both sets. So you would say what is shared between sets A and B would be 6 and 7, because those are the two numbers or the two elements that are in both sets. So like, let's do a quick example. Find the intersection of set A and B. So in set A, I have A, B, C, D, E, F. Set B, I have B, D, E, G. So I would say my intersection would be B, D, and E, because those are my shared. And of course, this is my little bracket sign. And I'm writing with my mouse here, so it may look a little weird. Let's keep going. All right, a union is when all the members of the sets get merged together. And it's going to be represented in this symbol right here. It looks like a U, literally, U for union. And what you're going to do is you're going to put all the elements or all the members of each set into one. Now, if you're dealing with a situation where you have elements that are exactly the same, you do not write them twice in the union set. You just write them just once, because once you write them down once, then they're present. Then that's all you need. Now, think about getting married, a union. You know, the guy, the girl, whatever. It gets when they get married, they bring all their stuff together. So, kind of like this here. Okay. Once again, find the union of A and B. All right, so that means, let's see, all the elements in set A are going into this, all the elements in set B, but we're not repeating anything. So that means 1, 2, 3, 4, 5, 6, and 7. Pretty simple. There we go. Pretty simple. Let's keep going. A complement of a set is elements that belong to the universal set but do not belong to A. Now let's talk about the universal set. The universal set, this is the gray box that has been kind of there in our Venn diagram. The universal set represents everything that is in the universe of that particular problem. And it's always going to be used as set U. Okay? Now in set U, it says that our universe is 1 through 10. So that means in this gray box, you have 1 through 10. But if you notice in set A, all the even numbers. So that means 2, 4, 6, 8, and 10. All of this is floating inside A's little bubble here. But then you have 1, 2, or not 1, 2, sorry. Then you have 1, and then basically all the odd numbers. 1, 3, 5, 7, 9. That's all this other stuff that's kind of floating around. So basically, what is in the universe that's not already in set A, which would be all the odd numbers. And due to time, we're going to label this part 1 because we still got some stuff to do. Thank you.